Hi everyone, my name is Denis Kimcharenko. I'm a software engineer at Cybervision, the company behind the Kaa open source IoT platform. Nowadays, there is a huge amount of new projects that need to solve a problem of messaging in IoT. During the implementation of those projects, engineers face with a bunch of challenges: how to define a variety of messages to exchange, find target devices to send message to, resolve unicast, multicast problems. Today I would like to present an end-to-end solution to IoT messaging problem, what is based on Kaa, purely open source technology. If you have any question, please feel free to send them over in the chat, and we will answer as soon as possible. Let me walk you through the agenda of today's webinar. We are going to start from the discussion on requirements and most common challenges what we all face in the development of various messaging flows. Then we are going to review key benefits of using the Kaa event subsystem. After this, we will review the reference solution architecture. Finally, I will proceed to hands-on part of our webinar, where we will implement an Android demo application to control GPIO pins on the ESP board. Then, the IoT-based definition is a network of physical devices which can exchange data, so there must be a messaging protocol. Every device performs its own function, so some of them supports one set of message and other group another set. By adding a device with new capabilities, a messaging protocol should be extended as well. So a messaging protocol must be extendable by design. The IoT world consists of potentially many thousands of objects, all exchanging information, so messaging should be secure and fault tolerant. To support constantly growing number of devices, a system should be scalable and guarantee low latency while exchanging data. So the main requirements to the IoT system messaging are extendable message protocol, security, fault tolerance, scalability, and low latency. But the list does not end here. There are other desirable features too. To support a wide variety of devices, a messaging system has to be platform independent. A self-validating message protocol is also an important feature, which allows reducing a number of errors, both during the development stage and in runtime. To minimize the load on the network, a messaging protocol should have a low footprint. So let's see how Kaa can help in solving the challenges mentioned before. Kaa is a middleware platform that connects devices and systems of various complexity. It distributes data to endpoints and collects data from them for further analysis. Kaa messaging feature allows messaging across endpoints regardless to their architecture, language, or the platform. But let's consider a few examples. You can remotely manage everything that you want, from the schedule of water irrigation to microclimate in your house. Kaa is applicable not only in home automation, but also for enterprise applications as well. One can build a tracking system on a solar plant, which collects and analyzes data from each solar panel and notifies an emergency team if something goes wrong. Let's highlight key feature of Kaa. Kaa is a feature-rich open-source IoT middleware platform. It's horizontally scalable and fault-tolerant. Kaa service can handle millions of endpoints. It also enables rapid application development using C, C++, and Java SDKs. By SDKs, it's meant software development kit, the set of program code what you may use to develop your application. Source SDKs are integrated with popular hardware platforms. For example, C SDK is able to run on quite small devices and consumes only 10 kilobytes of RAM. Let's assume what we want to build an application what will remotely control some consumer electronics. For the sake of an example, let us focus on the case of controlling a system of pins on a board. We will use LEDs to demonstrate the effect of control. In a real life, any other devices may be used instead of LEDs. For example, you can remotely control devices at your home. With minor modification of this project, you will be able to obtain the status of control and control behavior of our smart devices. Let me describe a potential scenario. Step 1. A user attaches all available board using an access code. This access code can be hard-coded during manufacturing or generated and visualized on the device. Once attached, the board becomes visible in the list. Step 2. A user discovers available boards and chooses a target board. Step 3. A user retrieves the set of GPIO from a target board and changes the state of the specified GPIO. By GPIO, it means General Purpose Input-Output. It's a common term what is used in some hardware platforms. So, the last step, step 4. A target board changes the state of the specified GPIO. Let's consider our sample application from a car point of view. We will use car event feature to build this project. The event feature allows devices to exchange structured messages between each other. We will be able to use this feature by integrating Kaa SDK into our application. We will use Android and C SDKs on mobile phone and ESP devices, respectively. Kaa sees all connected devices as endpoints. Kaa acts as a route of events between your connected devices. Only devices that are attached to the same user account can communicate between each other. According to the Kaa infrastructure, endpoints exchange events through a cluster of server nodes. This ensures horizontal scalability and fault tolerance. All events that are used in the event feature are completely user-defined. A Kaa event structure is determined by a configurable event class schema. It makes it possible to generate event object and related API calls in the endpoint SDK. By API, I mean Application Programming Interface. Such an approach enforces data integrity and validity and increases the development speed. Let's consider a flow diagram. Initially, an Android application discovers available devices, but broadcasting the device info request event. If such applications are online now, each of them sends a device info response event as a response. This event includes the device's model, name, and all available GPIOs with their state. When a user chooses a target device and changes the state of some GPIO, as a result, the device receives the GPIO toggle request and changes the state of a specified GPIO. Okay, let's proceed to the hands-on part of our webinar. I have posted some useful links to the Kaa documentation, to CarsonBox, and some to the project repository. So, first of all, we need the CarsonBox. So, go to the download page. Go to the download page, fill in the registration form, and save a Sandbox image on your machine. Downloading will take some time, so I have prepared an image before. Now we need to import the Sandbox and configure it. By double-clicking on the Sandbox image, launch the VirtualBox Manager and tell them to import the image. So you need to click on the import button, but I have done it earlier, so I only close this window. Okay, while the Sandbox is importing, I will say several words about the CarsonBox. Here is the documentation page. So, CarsonBox. Okay. CarsonBox is a private Kaa environment, which includes demo client applications. The CarsonBox includes all necessary Kaa components in a virtual environment that can be set in just 5 minutes. With the use of CarsonBox, anyone can learn Kaa, build a proof of concept, and test their own application locally. You can find more information how to deal with CarsonBox on the corresponding page of the Kaa documentation. So you can see this page. There is a video which follow you through all steps to start the CarsonBox. Okay, return back to our Sandbox. So the CarsonBox is already imported. The next step is to configure networking. We need to change several options in the network part of VirtualBox setting. So, go to the settings page, then click on the network panel and set attach to option to the bridge adapter, and then go to advanced and set promiscuous mode to allow all. Okay. Then we need to start CarsonBox. So click on the bottom, start. Okay. While CarsonBox is launching, I will tell you about the deployment process of the ESP8266 boards. So here is a documentation page on my screen, and let's tell several words about this platform. You can find the full instruction on how to do it in the Kaa documentation. So I said it before. There you can find the pinouts for both the flash mode and run mode. So here is table, the flash mode and run mode. Okay, this instruction is described the deployment process for ESP boards version 1. But I think it will be no problem to use more newer version of ESP boards. Okay. Also, the documentation will follow you through all steps what are needed to install toolchains to build application for ESP boards. So, Here is the steps 1, 2, 3, 4. And you can find also the example. We have prepared for you two examples. It is a configuration demo and GPIO demo. So as you can see, only what you need to deploy is to run build script. The script is put already in the archive with source code of the demo. All demos you can download on the CarsonBox. Okay, return to the Sandbox. As we see, CarsonBox is already started, and we need to find out which IP address is assigned to our Sandbox. So, to log in, we use default username and password. Kaa login and password is also Kaa. Okay, and start ifconfig command to find out the IP address. Okay, so we need the null interface, network interface, and as we see, IP of CarsonBox is 192 and so on. Okay, so we need this IP for further actions. So now we can go to a web browser and visit the CarsonBox page. Okay, so I take IP address of 192 and my browser give me advice. Okay, I need the Sandbox started, and yes. So this is a Sandbox main page. Okay, so the last configuration options remains there. We need to click, we need to change Kaa host IP. So click on the corresponding button and take the IP what is assigned for CarsonBox and put it in the field and remove HTTP and click on the change button. While it is configuring, I explain these steps. This step is needed to reconfigure Kaa interface of the virtual machine, because by default CarsonBox components are not accessible from the host network, and port forwarding is configured only for your local machine in order to give you an SSH and web access. Okay, finished. So click on OK button. OK, and return to the demo applications. So now CarsonBox is fully configured. But one more thing, all those steps you can find in the video on the CarsonBox documentation page. So, this page is this CarsonBox. You can find it there, CarsonBox. Here is this page. Okay, one more second, and video, which follow you through all steps. Okay. So let's say a few words about demo applications. The main purpose of each of them is to demonstrate on basic scenarios each Kaa feature. By features, I mean configuration, profiling, notification, event, user verifiers, and data collection. So you can filter demo applications by features. Okay. So CarsonBox is built in such way, as I said, you can easily filter application both by features and platform. Platform Android, Java, C++, and C. Okay, let's go on. In the scope of our webinar, we will focus on event feature and C and Android platforms. So I click on C, Android, and event feature. As you see, there are 3 applications marked as GPIO control family. So 2, and 3. Okay. In our webinar, we will use only GPIO control ESP, the first one, and GPIO control Android, the last one. So, as you can see, here is an instruction for installation and some description how to use this demo and some information useful. Okay, so let's review ESP application logic and code. You can find the source code on the GitHub repository. So this is the main Kaa project page on the GitHub, and we need sample apps repository. So click, okay, find GPIO control, yes, and source directory and ESP. Okay, all Kaa event flow is implemented in the Kaa demo source file. This file is located in source, and here is it, Kaa demo C. Okay, let's start from the main function. In the main function, we add listeners for the device info request and GPIO toggle request. And when application receives the device info request event, so this is callback, which processes this event. It responds by its model of a board, name of the board, and the set of GPIO and its their states. Okay, once board receives the GPIO toggle request, the GPIO toggle request listener, an application changes the state of the specified GPIO. So here is this routine to change the state of a GPIO. Okay, let's review Android application. The Android application has much more code because it is responsible for the entire demo flow, attaching and detaching Kaa endpoints, discovering online boards, and etc. So you can find code in the repository, in the same repository. So sample apps, GPIO control, source, Android, and here is code. Okay, as we see, a lot of Java classes here and here. Okay, let's dive deeper. Family of GPIO application use predefined event schema. So you can find this schema in the tenant admin page. So now we are going to tenant admin page. Okay, enter the IP of our sandbox and Kaa Admin. Okay, my browser. Give me an advice and enter Kaa Admin. Yes. To enter Kaa Admin page, you should use the default username and password. Username admin and password admin123. Login. Okay. You can see applications available now. Here are our applications. GPIO Control Master, it means an Android application, and GPIO Control Slave, it means application on ESP board. And we need event class families panel. So, as I said before, here is a predefined event class schema, what is used in our example. So click, and here are the predefined event objects. Device info request. Sorry, device info request. Back. Once again, device info request, device info response, and GPIO toggle request. Okay. If you want to provision your own event class schema, you need to click on the Add ECF button, click, and fill in all mandatory fields. Name, namespace, class name. Also, steps how to deal with event schemas are described in the Kaa documentation on the administration UI guide. Now I show you how to find this page. So go to the documentation, click on Kaa, and we need a left panel, and here is administration UI guide. Administration UI guide, click, and find event. So managing event class families. Click, and there you can find the full instruction how to configure how to provision your own event class family. Okay. Now I explain you how to generate SDK with your own event schema. So for this purpose, we need to go to the tenant developer page. Before, we are on a tenant admin page, but now we need tenant developer page. So I close administration UI guide and click on sign out. Sign out. Okay. And to log in to tenant developer page, I used also a predefined default username and login. It is dev user and password dev user 123. Login. Okay. There we need to click on our application, assume it's a control master, and click on generate SDK button, and we need event class families panel. So here is all available now event families, and add, and we need to assign user verifier to verify all Kaa endpoints. And we need to specify the platform to generate SDK to. So Java, Android, C++, and C. And click Generate SDK. So steps is how to generate SDKs with your own schemas. Okay. Console. So go to the demonstration of our applications. Now I am going to explain how to deploy application on the ESP board. I return to the CarsonBox page. Okay, CarsonBox page. CarsonBox page. And I need, firstly, I need to download the source code to GPU control ESP source code. And now CarsonBox generates it, and OK. And I need to save the archive with source code on the main machine, on my machine. So save. Okay. The second step is to deploy application on the ESP board. So I open the terminal and go to the directory where I have put the archive, downloaded archive, and unzip it. Unzip GPIO. Here is a directory, GPIO ESP client. So go into this directory. Yes. And here is all necessary source files and deployment script. We have prepared for you the deployment script. It's named build.sh. To deploy application on the ESP board, you should run this script with the deploy option. So deploy. This script builds, compile and link all source code and configure application to get able to connect to Wi-Fi access point. So start the script. It's a compilation process, and build script requires to enter Wi-Fi SSID. So we need to enter Wi-Fi credentials. So for a webinar we use Wi-Fi access point webinar, and password webinar 2. You are welcome to use your own credentials to your own Wi-Fi access point. So enter, and as we see, the application is built. Demo client. So the next step is to deploy this executable to the ESP board. When our build script requires user credential to perform this action. So if I enter my password, sudo password, the deployment process is started. So, but I have done it later, and only what I need is to show you how it works. So, as you can see, it is ESP board and attached LEDs, a yellow one and a red one. So I move this breadboard in more darker place, okay, and we need to install an Android application. So I get my camera and I try to get it more closer. So we need to visit Kaa Sandbox page. So I enter the IP address of CarsonBox one, okay, and visit. So to find Android GPIO control application, we can use platform filter, Android, and here is it. So to generate Android application, we need to click on the binary button, and CarsonBox is generating it. So it will take some time. I have prepared application, and I simply launch. I'm going to launch it. Okay. So here is a main page of Android application. So first of all, we need to discover all available boards. To discover boards, we need to enter its access code. Access code of ESP board is hard-coded in the source code of its application, and it is ESP8266. So I'm going to enter this access code. Okay, click on the plus and enter ESP8266. Click OK. So, as you can see, Android application have already discovered ESP board, and we're going to change the GPIO state. So we should to send a request to ESP board, and this board will respond with all available GPIO. So click, and as you can see, GPIO, ESP board have sent all available GPIO. There are null and 2 available pins. So let's try to change its state. So I get my camera closer to LED diodes and try to switch on null pin. Null, and as you can see, red LED is switched off, and try with yellow one. It's pin 2. Okay, and pin 2, yes. So try to switch off the red, the yellow, and again yellow, red. So as you can see, we can remotely change the GPIO state from an Android application. So now you can see how with under 200 of lines of code, I mean ESP application, you can build a solution for remote control of IoT devices. Kaa architecture allows you to scale the system to handle tremendous workloads in reliable fashion. So this is it for today. We will send you over to all the resources and links in the next 24 hours, so that you can try and experiment yourself. Thank you for attention and looking forward to welcoming you in Kaa community. Bye.